Creating assemblies in xDesign is a straightforward process that should be familiar to all experienced CAD users. Existing components can be added together in a design and then mated together to produce the intended motion. One way this process can be simplified is by creating subassemblies. By mating components together in a single design, it can be saved and inserted into another assembly. This means that if you have components that are assembled in the same way and used in multiple designs, that subassembly can be used repeatedly simply by inserting it into any assembly. It's important to apply the right mates to components to enable the motion you're looking for. By using a combination of concentric, coincident, parallel, perpendicular, distance, angle, and tangent mates, you'll be able to animate the assembly, bringing it to life so you can assess its performance. In this lesson, I'll show you how to insert components into a single design, including inserting subassemblies, as well as how to create each of the mates that were mentioned. Here I have a new component without any geometry added to it. The individual parts I'll be adding here will make up a subassembly, which I'll add later in this video to a larger assembly. But for now, I just want to focus on how to insert individual parts. To insert a component, click on the Assembly tab of the Action bar, then click on the Insert button to add an existing component. This brings up all the designs I've saved. I want to add this mounting bracket into the design, which I can do by clicking on it and then clicking OK at the bottom. This adds the mounting bracket into this design. I'll undo inserting this component to show you another way it can be added. If I click on the search bar at the top, I can go to the My Content menu by clicking on it. I'll find the mounting bracket again in the menu, and this time I'll drag it on screen. It jumps back to the component workspace. When I let go of the mouse button, I can either open this file directly, or I can click this button to insert it into the design. I'll insert it for now. And the component is added. Notice how there's a lowercase f next to the component name. This means the component is fixed in space and can't be moved when I try to click and drag it. This fixed setting is automatically added only to the first component placed in the assembly. From here, I can continue to add other components. I'll add a socket head cap screw into the design. Notice that this component isn't fixed, which is because it's not the first component added. I'll add another component, which is the hex flange nut component, and it's added. These components can be moved around in the workspace simply by clicking on a component and dragging it to a new position. To rotate a component on screen, hold down the Alt key while clicking and dragging the component. Components can also be repositioned along an axis or rotated by a specific angle using the triad that appears when you click on the component name in the Design Manager. For instance, if I click on the cap screw, the triad appears and I can move it by a specific distance along an axis, or I can rotate it by a certain number of degrees around an axis. And if you need to move or rotate a fixed component, you can click on its name in the Design Manager and then select Float Component from the Context toolbar. Now it can be moved and rotated around in the model just like the other components. I currently have one of each component type added into the model, but I need another one of each to create this assembly, which will later be added as a subassembly to a larger assembly. To add duplicate components, simply hold down the Control key on your keyboard, or Command for Mac users, and drag the component into the workspace. This automatically adds a duplicate and drops it where I released the mouse. I want to add another mounting bracket, a sock head cap screw, and a hex flange nut so I'll hold Control or Command again and drag another mounting bracket into the design, followed by the cap screw, and finally one more hex nut. Now I have all the components I need to create the assembly. Mates are used to relate the components to one another, which I'll cover in depth in the next video. For now, I'll skip ahead to show you the assembly with all the mates added. Here all the components I added are connected to one another as a single assembly. To save it, simply click on the Save As icon in the action bar. Give it a name such as Mounting Bracket Subassembly, and click Save. Now this assembly can be added into another design along with other components. I'll create a new design, then add some new components such as the actuator arm, pin large, pin small, a linkage, and a finger. Now I want to insert the subassembly I created. I'll insert an existing component, click and drag the subassembly, and it's added. The subassembly acts as a single piece of geometry, moving and rotating as one. To have all the necessary components in the design, I need to add duplicates of all the components except the actuator arm. I'll drag in a duplicate of the finger, a second linkage, another large pin, and 3 more small pins. From here, the components would be mated together using a variety of mate types. The next video will focus on how to use the different mate types to relate these components to one another, completing the full assembly and allowing for the parts to move so the fingers can grab and release objects. Here I have all the components I need to create the claw assembly, including the mounting bracket subassembly I showed in the last video. I've also mated some of the claw components together already, and I'll show you the remaining mates needed to complete the assembly and add motion. To relate all the components together and create the assembly, I'll need to add mates that restrict the degrees of freedom and connect the components. There are different kinds of mates that limit how the components can move relative to one another. To begin, I'll show you how to add a concentric mate, which forces 2 cylindrical faces to share a central axis. The components can spin around that axis, but they must align within the cylindrical faces. In this example, I want to make this hole on the mounting bracket, this hole on the left finger, and this pin all concentric with one another. Instead of enabling a mate command like you may have seen in other CAD software, simply hold down Control or Command for Mac users and click on all the faces that will share the same mate. I'll select the face on the mounting bracket, the hole on the finger, and the outer face on the large pin. When I do, a context toolbar appears with the different mate types that can be applied to the selections I made. This first icon is concentric, which is the one I'm looking for. When I click on it, the components move in space and align with one another. Now all 3 of them will remain concentric, keeping them lined up at all times. With the claw connected on one side, I can add the concentric mate on the other side as well. Once again, I'll hold Control or Command for Mac users, and then select all 3 cylindrical faces on all the components, and choose the concentric mate type. Before adding more mates, I want to point out that the mates I've created can be found here in the Design Manager by expanding Mates. From here, they can be deleted or edited as needed. The next mate type I want to demonstrate is the coincident mate. For many users, this is the most frequently used mate type. It takes 2 faces and forces them to directly contact one another. This can be used in a variety of situations. For this claw, I want each pin to be positioned so that it lines up with the bottom face of the mounting bracket, and I want the bottom face of one of the fingers to be in contact with the inner face of the mounting bracket. First, I'll make both pins coincident with the bottom face of the mounting bracket. I'll rotate the view, select both bottom faces of the pins while holding Control, and also select the bottom face of the mounting bracket. When the context toolbar appears, the coincident mate is shown first as this icon. When I select it, the pins move downward and line up with the bottom face. If needed, the orientation can be flipped so that the faces line up in the opposite direction. Many mate types provide this option in case you need to swap the orientation. I was able to mate both pins at the same time, making it easy to line up multiple components using a single mate selection. I also need to make the fingers fit in between the mounting bracket. To do this, I'll select the bottom face of one of the fingers and the inner face of the mounting bracket. Select Coincident, and fingers, linkages, and actuator arm all move down to fit within the mounting bracket subassembly. Next, I want to show you how to create a parallel mate. This forces two faces to remain parallel to one another. This is similar to the coincident mate, except that the faces don't have to be in contact with one another. In this design, I want the actuator to slide forward and backward within the mounting bracket without rotating. Creating a parallel mate will keep the actuator straight. To create it, I'll select this side face on the back of the actuator, and then select this side face of the mounting bracket. When I click OK, the actuator is forced to remain parallel to the side of the mounting bracket. The perpendicular mate type is very similar to the parallel mate, but as you'd expect, it forces faces to be at a 90-degree angle at all times, rather than parallel. So if I go ahead and delete the parallel mate in the Design Manager by clicking on the three dots and then selecting the trash can icon, I can add a perpendicular mate to define the actuator. I'll select the side face of the mounting bracket like before, then choose the end face of the actuator arm, choose perpendicular instead of parallel, and click OK. Now the claw produces the motion I'm looking for when I move the actuator back and forth. The fingers open and close from the actuator's linear motion. The next mate type I'd like to show you is the distance mate. You can think of this as a parallel mate that sets a fixed distance between the two selected faces. In this design, you may want to test what angle is produced in the claw when the actuator is a certain distance back. This means I can apply a distance mate between the back face on the actuator and the back face on the mounting bracket, and choose the distance mate option shown here. Notice the entry box for the distance. This is where you type in the distance value, which in this case I'll set to 45 millimeters. If needed, the distance can be flipped or the orientation of the components reversed. If you want to specify limits for how far these two components can move away from one another, a minimum distance and a maximum distance can be added, allowing the components to move freely apart from one another up to the distances specified here. I'll use these limits in a later video when assessing the motion of the claw. For now, I'll click OK. And the claw is closed, determined by the distance the actuator moved back. Let's say you wanted to do the opposite, set the angle of the claw and determine how far back the actuator has to move. To do this, an angle mate can be added, which specifies the angle between two faces and keeps them at that angle. For me to add the angle mate I'm looking for, I'll delete the distance mate. I want to specify the angle between two inner faces near the end of each finger. I'll select the first face and the second face, and then choose the Angle Mate option in the context toolbar. As you saw with the distance mate, there's a numerical entry box to type in the degrees. For now, I'll set it to 120 degrees for this angle. Similarly, limits can be added to the angle that these faces are separated by. If the claw was intended to only open between 90 and 180 degrees, these values could be entered here, and the fingers will now move within that angle range. I'll leave the mate set at a fixed value with the limits included, and click OK. Before I show you the last mate type for this video, I want to mention that all aspects of each mate can be edited at any time. For instance, if I wanted to go back and adjust the angle mate I just created, I can either double-click on the mate, or I can click here in the Design Manager next to the mate name, and click on the Edit button. This brings the same mate dialog box back up on screen. Here I can click on any of the X's to remove a face selection, or click here to remove them all, and I can change the angle value. I'll change it to be 150 degrees, and click OK once again. To show you the last mate type, I'll delete the angle mate so it doesn't interfere with the new ones being added. The last mate type I'd like to show you is the tangent mate. This mate keeps a cylindrical or spherical face in contact with another cylindrical, spherical, or flat face. The main reason I'm showing this mate type at the end of this video is that I'll need to add another component to use this mate. I want the claw to actually be holding an object between the fingers, which in this case will be a cylinder. I'll go ahead and insert the cylinder component. I'll add 2 tangent mates, one for each finger. To create the first one, I'll select this flat face on the tip of the finger, and select the cylinder, and then choose the tangent icon shown here. Now the cylinder moves in place, and if I rotate the view, you can see it's in contact with the finger. If needed, clicking the flip option will reverse the orientation of the faces made tangent to one another. I'll create another tangent mate for the other finger by selecting this face and the outer face of the cylinder, and choose Tangent. Now both fingers are closed around it, simulating the claw picking up an object.